Hey, Fry has joined and Zaid has joined and Firas has joined. Good morning to you all. I want to thank you for coming in.
My pleasure.
Hey, great. I don't have an agenda for this morning's meeting, so as I said, I put out half a dozen videos over the last 6 weeks or so, and I thought that today would be a great time to have a conversation about them and ask any questions or answer any questions and stir up some more conversation. And one of the things that I'd like to point out is one of the videos is about building an algorithm within your brain to compare two numbers. And this came directly from a question that William asked, where this was about 3 months ago now, that William asked, well, how do you know that two numbers are different or the same, or one is greater than the other? And clearly your brain is capable of doing this, and clearly it's turning out to be a non-trivial problem. And I made a video about it, which asked more questions than it answered. And now William is working at writing some code to see if you can actually do it, which I think is outstanding. But I wanted to just address that. That's one of the things that comes out of conversations like this, that we ask an interesting question and then we figure out that, well, we really don't know the answer to that, but here's some ideas and here's some other ideas. And as we get together and talk about it, maybe we'll come up with some solutions. So at that, we'll throw it open to the wide world and ask if anybody has a question, a comment. Has anybody seen any of the videos? Want to make a suggestion or how to make them better or anything?
As usual, I have lots of comments, Charles. I watched 5 out of the 6. So
good.
I didn't quite complete my homework. So first question. Well, first of all, I loved it. You make great videos. I just enjoyed watching them. They were just fun. On the first one, there was a slide where you said ChatGPT made up a whole bunch of words like abstractorium, mathematter, and holoid. Are these words that were made up by ChatGPT, or are they known in the industry? I'd never heard them before.
Well, I don't know, but my suspicion is that ChatGPT very seldom says anything that it hasn't read somewhere else.
Yeah, okay, but I couldn't find holoid on Google, just a regular search. So, okay, well, that was just a simple one.
But do you agree with that? I think that that's my supposition.
Yeah, well, I love the words because they combine, this concept of like a holoid, well, it's hollow, but it's also solid. And I was thinking of foam. And foam,
sure,
or an aerogel or something. So I like the conceptual thing. Okay, a little more important here. You use the word statement, and I hate the word statement because in programming languages it means a variety of different things for different languages, and I just don't like it. Okay, I like the word assertion. And I think maybe you're using that, but you didn't use the word statement very much in the rest of the videos. Now,
unfortunately, there's a function call that is named add statement when it should have been named something else. Maybe I'll go and rename it.
Well, okay. But this is sort of the deeper level on glossary here. I think you are conflating, you're using the word relation or relationship to mean two different things. One is like is-a, and another is the whole assertion, like Fido is a dog. Am I right?
Mm.
And I have a bunch of examples like this, but I like to be very careful about, are we talking about we're talking about the middle of a triple versus the entire triple. And when you're talking about clauses, and what is a clause, right? And so that's where it comes in. What is a clause? Well, I think the if is a relation, or I'll call it the little term relation between two assertions. Not if is not a relation between the two relations in those assertions. It's really about the whole assertion that the relationship is.
For me, the relationship is, to start off with, we'll say it's 3 nodes. It's a source node, a target node, and a relationship type.
Good.
Now, the question is, when I say it's these 3 nodes, within the computer, we know it's pointers to these 3 nodes.
Yeah.
And so are the nodes are not really part of the relationship. They're somewhere else. Right? And
yeah, I don't know, but you just use another term, relationship type versus relationship, and those two terms are too close to each other to use to distinguish something.
Do you have a suggestion of a different thing to call it? The relationship type?
Well, I just call it relation, or you could call it relationship type. I don't care. But the important thing is the assertion is the triple, and then it has a source and a target and a relationship or a relationship type. I don't care which one you use.
Okay.
Relation is simpler, but you know.
Mm-hmm.
Okay. So that's a vocabulary thing, and it was tripping me up in a lot of ways. Okay. Now next is how do you use the dot syntax? What does dot really mean in the UKS?
In what context?
You have Fido can dot play frisbee. Yes. So dot is some kind of a connection between can and play, but what is that connection?
It is a convenience to help you look at the UKS and understand what's going on inside it.
Yeah, okay.
It doesn't mean anything to the functionality of the UKS because it's just a label.
Yeah. I know, but
and so what I did when you create when you create a node that is a subclass of dog that is brown.
Yes.
I said, for our convenience in knowing that this is a subclass of brown dogs, let's call it dog.brown.
Okay.
That's
so
all that's there.
So does it mean that? Well, okay. Let me just roll another idea out of left field to see if this works. I was thinking that can is a node.
Yes.
And it has a child node of play, so that play is a can. It's a kind of a can that is a kind of a can that has play, that is distinguished from the other cans by it's a playing can.
Right.
Okay, so now if we say can.play, then we're really saying, well, we can imagine play could be in some other context, so we're just giving it the context. We're giving it the parent to help distinguish what kind of play it is. It's a can play. And we might have an is play or a has play or some I don't know, what other, an event play, which is actually a play on stage, theatrical or something, right?
Yeah, well, this is a really interesting question in that you got to know how we're going to compound things.
Yes.
And so playing is an action. And so it's definitely it is definitely a relationship on its own, like Fido. we would say Fido plays fetch.
Okay.
So play is a relationship on its own. But now we want to say that he is capable of it, but he's not doing it now.
Oh, nice.
And that's what can means.
Oh, nice.
And the way I did that is that I made a new node, which is a subclass of can. And it has the attribute of play in the same way that dogs are brown. A class of dogs might be brown. And then I put the label on it so that it would make some degree of sense in English.
Yes.
And just to make it look like it makes sense in English.
But then we have to choose like which attribute of this subclass is going to be the distinguishing one that helps us understand.
Exactly. And so can must have a whole slew of other attributes that let you know that it means that you're not doing this right now, but you have the capacity to do it sometime. But the implication is that you're not doing it now.
Yeah. Okay, that's good. And so this is very related to, the big issue I've been talking to you about for a while. And at one point you were talking about the UKS, and you said we're representing the is-a relationship through this hierarchy, but it's just a relationship like another relationship. And an example of another one is.
Yes.
And so, well, okay, is, what the hell does that really mean? It's kind of ambiguous, but, Fido is brown. And then I want to ask the question, what color is Fido? And in order to answer that question, we have to go to Fido, realize that color is somehow related to is, I think, then search through all the is relationships, because Fido has a lot of them, and look for a target node which has a parent of color.
Exactly.
That's how you do it. Okay, so that's a little tricky.
Except you have to remember that when you say, I want to look at all of the is relationships, we have the capacity in a virtual computerized brain-like sort of way. You can search all of those relationships in parallel to see if there's a parent of brown. Okay, so it's not an arduous task where you have to go through 100 attributes in series.
Yeah. Well, that's another question I want to ask about series. But okay, just to dive a little bit more about it. So then I said, okay, what if you have Fido is brown and Fido is white? So now we're representing that Fido has two colors instead of one, okay, because they're both colors, right? But now if we want to say a little more nuanced, Fido has white paws, but Fido has a brown tail. Okay, now it's still true that Fido is brown and Fido is white, but we can, how would we represent both of those at the same time? And how do we represent that Fido has white paws versus Fido has a brown tail?
Yes. Well, let's just walk through that. How might we do that is first, let's back up a square and using is and has and these things like
good.
Well, let's say has the attribute of.
Okay.
So we don't have to. Although in your context, I think you're saying he has implies that it's a component of him. And
we might use part of as a relationship.
Yeah, exactly. And
so we could do it with part of, and part of Fido is paw, and part of another part is tail, and then each of those.
Exactly. And so we don't have a problem in representing that. I don't know if you can search it very well, but if you simply
we could search through Fido's. If we ask what color is Fido, we might not have any direct Fido is brown, but then we say, well, let's go after his parts. And we'll look at the parts. We say, oh, one part is white, one part is brown. Okay, so what color is Fido? Fido is white and brown.
Right, and the same. Okay. One of the that a real key point in order to making that work is we can all agree that ISA has the special characteristic that properties of the parent are inherited by the child.
Yes.
Okay? So properties of the parent are inherited by the child, and this inheritance characteristic is also true of the has, specifically has in terms of contains, or part of, or include, or as part of, is also inherited.
All right, that was the secret. So is some of these relations inherit and some don't?
ISA is always inherited.
Yes.
And is not. Or has attribute is not.
Okay.
But contains or has a part is also inherited. And so the mechanism for inheritance also is more general than just ISA. And I haven't explored, but there are undoubtedly some number of other uses of this inheritance characteristic in addition. In the same way you can find lots of relationship types that are transitive, for example.
Yeah, okay, all right. Well, it's a little different. You know, when you say that Fido is brown, we're looking at him from, afar, and we're seeing just a general brown color. And that's a little different than saying Fido's tail is brown. Right. I'm a little nervous about, regular ISA, I know what that is. I'm a little nervous about applying exactly the same kind of inheritance to has part as is It just semantically some nuances there.
So what we're going to do is we're going to say that Fido has a part of a tail, and the tail has the attribute of being brown.
Yes.
The tail may also have an attribute of being long.
Yes.
And he has paws, and the paws may have an attribute of being white.
Yes.
You have to get into genitive cases of nouns. Possessive cases.
Exactly. Well, I'm trying to make sure we differentiate between possession and is part of. Because Fido has a collar does not imply that Fido necessarily has the parts of the collar.
Well, so yeah. So has is different than part of, for sure. And so you have to get all these nuances. But I don't think it matters in, like in an initial system. I think these distinctions will eventually be evolved. So what's it called? Colligative parts versus, like possession. I think those will be, sorted out later. I don't think you can, Psych spent 30 years knowledge engineering all of this, right?
Yeah.
Yeah. Hey, well, while we're here, four of you have been relatively silent. Do you want to pitch in with a question or dive in with a comment?
Good videos.
Is that for us?
That wasn't me that yelled out, but I just unmuted myself. Yeah.
Oh, okay. Who was that?
Okay.
Okay.
Well, I mean, I agree. Good videos. They're what brought me here. But I'm a little bit confused. I haven't used Brain Simulator, so maybe I don't know what I'm talking about. But going way back in this linguistic discussion, why are the properties a subclass of the verb is
lost the audio
instead of the other way around? Because as far as I got, you have the two nodes, and then they're connected by the verb is or has right? So surely it would make more sense for the verbs that can apply to an adjective or a noun or whatever to be the subclass themselves and not the other way around. But I don't know if that's just, because I don't have a lot of knowledge on the topic.
Let me give you a general response to your comment, and then a more specific response to your comment. And in the general case, it could be done either way. It would work fine. And because the graph is general, it would all still work. And so I chose to do it this way because it looked easier to program at the time. And it seemed more straightforward, but you're absolutely correct that it could go. When we're talking about graphs, there are a few things that I believe are absolutely essential. Like you have to have an is-a capability, and you have to have certain exclusivity things. And it's a relatively small number of processes, but within that, the graph could grow any way you wanted it. And there's no reason to assume that the internal mental graph that different people have are the same. I mean, you could do it one way and I could do it the other way in my mind, and it would all work.
Except when you want to communicate between those two people, and then if they don't have some conventions or some similar or a Rosetta Stone to convert, they're confused and they can't talk to each other.
Well, to some extent, what I'm saying, Pry, is that you can, because the graph is really independent of the language, you can have an input and generate an answer. And the graph of information in between the two could be seriously different and still get the same results.
Yeah. We can have dictionaries that translate between French and English for vocabulary. I'm not concerned about that. It's more the grammar. It's more if the structure is different between them, then we're going to have a real hard time asking questions that make sense.
And I agree with that. And the question, I mean, which came first, chicken or egg? Is our mental state and our organization of our minds defined by the grammar of the language we learned when we were 2, or is our language built from, over evolved so it matches the evolution of our minds?
Yeah, well, both I would say are crappy, and me and you try to make better abstractions like the UKS.
Mm-hmm.
So Jean Piaget has an answer to this, right? I've been studying Jean Piaget for a while. He says that our understanding is always partial, if not non-overlapping, and unless we have telepathy, which the robots might be able to have, but unless we have telepathy, our understanding is always going to be partial and always going to be refined over time to approximate asymptotically what the other person means. And we just have to go with what we have, because number one, our groundings are all different. My experiences with cat are different than your experiences with cat, but we seem to have a general idea what that cat category is, and it just goes from there, So we can assume that understanding is always partial, communication is always misunderstood, but we can refine the communication over time.
Thank you, Michael. That was excellent. So now we say, if we can make a artificial language, let's call it a programming language or something like that, right? Where we define exactly these terms, and then both humans, learn this one language and couch their expressions in terms of their language, then our understanding can be maybe not complete, but much closer to 100% than the partial that we use when we're each using natural language, or you're talking French and I'm talking English.
I think you're also, like at the beginning, you said, fine, we can have a dictionary to translate between English and French, and the issue is the grammar. I think that's not really a valid distinction, because the grammar between English and French are already different. And then if you pick a different language, the grammar is going to be entirely different. So if you have a way to translate, you're already dealing with the differences in grammar, right?
Well, I guess it's just which is hard, right? And if there's a concept, a word like mañana, it might mean one thing in a literal translation, but another thing in a sort of a conceptual translation. So,
yeah,
and they've been working on interlinguas for a long time. Interlingua, they call it. They've been working on that for the long time.
One of the things that I'd like to reiterate is I am absolutely convinced that your mind thinks independently of language. So you can have a thought and then you can think, you know exactly what you're thinking about. It's unambiguous when you're thinking about it, and you can express that in lots of different, using different language. And other people will understand your language and they will understand it differently from you did, but they will have a thought that is also entirely unambiguous to them, although there could be, I mean, maybe it is highly unlikely, but perhaps you have exactly the same internal thought and representation. But for the most part, everybody understands things a little differently.
Well, I'm shocked you said absolutely convinced that your thought is different than mine. I think we use language in our brains, but let me give you a hypothesis here.
Okay.
The reason the SATs like you to know vocabulary is because to know a word is to know its meaning. And if you hear, and usually how do you learn the meaning of a word? Well, you first hear the syntax and you go, I don't know what that means, but people are using it. And then through context, or maybe you look it up in a dictionary, you learn its meaning. And now you have this word to hang the definition, which is much more complicated, off of. And then internally, you can use the symbol of the word in your brain and pass that around without passing around the whole meaning. And then it helps you to think, because you can do this shorthand within your mind, as we do within people, of just saying a word rather than the whole concept.
Mm-hmm. There are a couple of other people online that we haven't heard from. I want to make sure that you're invited to participate in the conversation if you have a comment or a question. Fabio, are you there?
Hi. How are you? Well,
Good.
I'm just listening all you guys here. This is just like a new thing for me. I found the Future AI a couple weeks ago, so I'm just trying to follow you, the chain of thoughts.
Welcome aboard.
Okay, thank you.
Sure. Anybody else? William, we haven't heard from you. You have questions, I'm sure.
Sorry.
No, nothing at the moment. Okay. By the way,
I was thinking. Oh, sorry.
Yes, go ahead.
I was thinking, all the examples that you showed were still kind of specific. Like you were mentioning the concept of a cat or a dog, but how would it deal with some very abstract concept, like say beauty, where you can, if you see something that's an example of beauty, you know what it is, but you can't really define it.
Tough.
It's made up from the examples.
Yeah.
The category is made up from the examples.
But what about when you first hear?
So you don't have to necessarily define it. You can just make a category based on the members.
Make a definition based on the members of the examples. Yes.
Well, no. It can. So you have a category object. Consider if we're programming this, right? The category object can be a category constructed from examples.
Mm-hmm.
And when you say beauty, what comes to mind?
For the category?
Sure.
Yeah, well, for example, it might be constructed of examples of what you find to be beautiful, but even we don't know exactly what we're going to find beautiful until we see it.
Mm-hmm.
Absolutely correct.
So,
and when you see it, then you stick it in that category too.
Yeah, but there would have to be some mechanism to classify things as beautiful or not that already exists to build up that pool of examples.
Mm-hmm.
Absolutely correct.
But
we need mechanisms. You need mechanisms along the memory.
Right. And one of the things that I would say on that is that obviously you have an innate set of preferences, and beauty is pretty abstract, but if we said taste, there are tastes that you like inherently and there are tastes that you don't like, and this may evolve over time, but now you can put everything you taste on a sliding scale of, do you like it or do you not like it? And beauty's a little more abstract, but somehow you've got to have these innate things in that are absolute, that are programmed into you instinctively. And one of the things that I point out in this, that when you build AIs or robots, whatever you chose as good taste or bad taste or pretty or ugly or whatever were the standards for a human, you're clearly going to have different standards for a robot or for an AI. So whatever you have as an AI, it will never act as a human because it has to have a different set of standards, because it has a different set of innate senses and innate pre-programmed ideas.
Yeah, I guess that makes sense, but then that gets into the debate about, what we should set the defaults to.
Excellent. What should we set the defaults to is going to be key to our survival. and
there's preferably there's no defaults. Preferably the system learns on its own, and the system will acquire its own set of categories. The question is, are we going to build an ontology for the system, or are we going to let the system evolve on its own, develop on its own?
Or maybe we could do both, because there's, like, for example, your favorite color. How do you learn that? I think you kind of have to pre-program that in there.
And also,
not necessarily.
We have something, an innate programming into humans is we want to have stuff, and we accumulate stuff. And there's certainly no need to give that pre-programmed desire into an AI. And it probably would be a negative if we did. But we can see that there's a real evolutionary advantage for us humans to have stuff, but AIs don't need stuff, so they don't need that instinct.
They need power.
Yeah, exactly. That is,
that's
as an electricity, not political power.
Well, Michael, you made an interesting comment about we might not necessarily have to program in your favorite color. And I was thinking about that. I was thinking, like, well, when I was a little kid, I didn't really have a favorite color. And then, I don't know, somebody suggested it was a good idea to have a favorite color. And I kind of like the color green. And, then I kind of was into green for a really long time. But then I decided, like, later, I don't know, my 20s, that purple was really, a more beautiful color than green. And I kind of switched. And it wasn't, God didn't come down and tell me thou shalt have green as your favorite color. So it wasn't really programmed in from the beginning. Somehow it was emergent behavior. Behavior is maybe the wrong word, but.
Yeah, it's just your response to a question. The first time somebody asks you a question, you just pick the color.
And your taste, if we do something that's a little less abstract, your tastes of, sweet and sour, can evolve over time. First time you had a beer, perhaps it was not the tastiest thing you ever had, but you grow to appreciate things.
Acquired taste.
Yeah.
I think the concepts like beauty and taste and whatever don't matter maybe that much, because if you're going to have a robot learning from its environment, the same thing is going to happen with something concrete like a dog, right? It sees a dog, it doesn't know what it is. Let's say it like works out that it's a separate object to the environment. We've got past that point, and then you tell it this is a dog, for it to build its graph in the background. You do the same thing with this is an example of beauty, right? I feel like it's probably going to be treated the same way if it's concrete or abstract. I'm not sure how much water that holds, though.
I like that within the graph, beauty is just another class, and
how does it build it unless we're manually putting it in there, right? If it's
exactly
just learning from experience,
so it will evolve to say, well, you know that sunsets are beautiful and beaches are beautiful, and then you get to decide whether or not you think mountaintops and cities are beautiful on your own.
So there was a Twilight Zone episode called Eye of the Beholder. And in that episode, this woman was undergoing surgery to correct deformities that she had. And at the end of the movie, at the end of the episode, you find out that when they unwrapped her wrappings, bandages on her face, you found out that she looked like a normal person. And then they turned the camera to everybody else, and they looked like big people.
Mm-hmm. I think I saw that.
And so, yeah, Eye of the Beholder. And so, beauty is just a placeholder for some examples.
Yep.
And she said that she was ugly. I'm ugly when she wasn't, by our standards.
Mm-hmm.
I got
a whole slew. There were a whole slew of interesting comments on the videos themselves and questions that I put that I got a couple of and one of the ones that interested me is what's the relationship between things and relationships, and it struck me as I built the picture of the relationship having three corners. A target, a source, and a type, that and then I invented clauses as having something else. But if the relationship itself is a node and it has pointers to the source, that target, and type, then it can also have pointers to the if and the other clauses. And so you can hang the clauses on without the special special software goodies that I put on it. And I think that clauses that make information conditional are one of the things that most AI is missing, and one of the things that really sets us humans apart at the moment, that we know information is largely conditional on other information, or only important in certain respects. And I handled that with clauses because I couldn't figure out any other way to do it. But now I can see that clauses can be built within the context of the existing graph of nodes and edges.
What is an example of a if clause?
That Fido can play fetch if the weather is sunny. And so okay. you don't know the truth of Fido can play fetch unless you know the condition of the weather. That is, Fido can play fetch is neither true nor false except in the condition until you've evaluated all of the conditional clauses. But I also use clauses to link things like Mary and Jane went to the store together, where just knowing that Mary went to the store and Jane went to the store is not the same as knowing that they went together, or Mary went with Jane.
Oh, together is a relationship between those two assertions.
Yes, it's a relationship between assertions, which is yet an assertion on its own.
Yes. Good.
And so what that means is that we need to look at the assertion is actually a node in the graph as opposed to an edge.
Yeah.
Well, I haven't written it that way, but that's how I can see where it's going to end up and how it must already exist in a brain where you don't have this kind of dichotomy between relationships and relationships of relationships and clauses and things like that.
I have a different topic, Charles. In one of the videos, you were talking about the serialization in the mind and how it must do certain things in serial. But in this conversation, you mentioned that we can do things in parallel to speed them up. And we know that, we can both see and hear at the same time. So they're kind of parallel. So I want you to dive down a little bit more about what did you mean in that video saying you've got to serialize certain things?
And I know Michael's talked about this in things he's done also, is that as you encounter events, you know that Fido is a dog, and then I tell you that Fifi is a cat, but you know instinctively that I told you that Fido is a dog before I told you that Fifi is a cat. So you have, in addition to building the specific factual relationships, is you're building other kind of sequential relationships about when you learn this
time-stamping info. Yes,
sort of time-stamping, but in a brain you can't timestamp stuff. You can only have a continuing set of relationships to say this happened before this and after that and after that.
Mm-hmm.
And so this happened directly to the question that William was working on in numerics, that you know that 2 is greater than 1 because it comes after 1 in the sequence of numbers that you learned on Sesame Street. So all of this stuff has to be going on in the background, that you've got all of this factual information, and at the same time, we have to know that there's a sequence to things. And that's going to be, first, it's a necessity in being able to understand language, because you have to know the specific order of the syllables, and you've got to know the specific order of the words in order to make any sense out of it. And so you have to be able to store this serialization kind of information. And I just presume that there's a came after or a comes next kind of a relationship type, and you can hook these things together. But
I call them. So go ahead.
No, you go ahead.
Yeah, in my video, Unlocking Artificial Minds Coordination, I go through a section called Association. And in association, I talk about a whole host of associative relationships, including tandem, where one thing comes after the other, and then series, where a bunch of things occur in series.
Right. And another thing that I pointed out in one of these videos is that you have no option except to record all of this stuff, because you don't know, if you would like to know that A came before B, you have to have recorded A in order to be able to know that it precedes B. And so you have to be recording essentially everything and discarding the overwhelming majority of everything that you encounter. Because if you have a cause, you want to eventually decide that this is a cause and this is an effect, you have to have stored the cause and the effect, and you may find minutes later that it was important.
Mm-hmm.
And so you have to have the memory sitting there in order to be able to say, oh, that was important, I better remember that.
Mm-hmm.
And this puts a different picture in of how you're going to handle information flow, when essentially you have to remember everything and everything you can possibly know about everything. And now it's a problem of discarding rather than a problem of selectively storing. You're simply going to store everything you can and immediately start discarding stuff.
Mm-hmm.
You throw away the stuff that's not integrated into the whole, and then if you encounter it again, you encounter it again. The integrations allow you to keep it.
Yeah,
Usage
and
count.
this is a problem of that we humans, that ChatGPT doesn't really have. It's perfect. I mean, it's perfectly capable of remembering everything. Should they choose to store it that way.
I call it an eidetic oracle.
Yeah. So when we're building this is another instance where we're building an AI and building it with human-like properties. May or may not be particularly advantageous. Now, I think that we ought to pursue the human-like properties because of the areas where AI currently falls short, and we'd like to be able to fill those in. But that doesn't mean that necessarily that's the best way to go. It's just the way we currently do it. We humans, that is.
Mm.
Hey, as we begin to wind down today, what I would like to ask each of you is what can we do to make these videos better, make the society better, make the conversation better? What would you like to see in order to make this more useful to you?
Well, I would say an API to the web and, be able to, access this stuff from JavaScript or my web pages, because I can see how this knowledge is extremely valuable and can be better than an LLM. I am using LLMs now, but there may be some combination between the two. And so easy programmatic access over the web would be, a game changer.
Yes. Who would volunteer to help me do that?
Yeah. Well, I'm thinking about it, Charles. I'm mainly working on Justify right now, but Justify needs to have some reasoning to it. And this is the kind of stuff that it needs in the way back end.
Well, the process, the way software exists today in .NET, since the UKS is a .NET DLL, building a .NET data structure and making it compatible from the web is not impenetrably difficult. But once you do that, then you have to put it on a website somewhere and maintain it, which means it's an ongoing.
The hackers out and denial of service.
Exactly, it's an ongoing, continuing effort.
Yeah, I hate that stuff.
Yeah.
And my only solution to that, my real solution to that, is solve poverty, and then people won't be paid to or have a financial incentive to do all this hacking garbage.
Yeah.
Elon Musk recently had a video on YouTube about unlimited abundance. He said the robots will bring us unlimited abundance, but I don't think he talked about replicators.
Replicators?
Star Trek replicators.
Oh, okay. Yeah. Yes.
Well, and relate. Okay, so related to, we introduced politics and economics in here. Early in I think it was your first video of the 6, Charles, you mentioned that, the human mind can do lots of stuff and it doesn't need a nuclear power plant to power itself. And yet now we've got, I don't know, Sam Altman and, Mark Zuckerberg and things saying, well, we need to build a new nuclear power plant to create the models for the coming AI. And this drives me nuts. And I imagine both you, Michael Miller and Charles, are just like tearing your hair out on this, right? No, we don't need to do that.
I started to make a video in that direction. And one of the things that I figured out is that again, it's difficult to get information, but if you say ChatGPT is handling hundreds of requests a second, it's equivalent of many thousands of human minds, and many thousands of human minds at 20 watts apiece is also a considerable amount of energy.
Okay.
I started to go down that road and decided I didn't know enough to be able to finish that off.
Fair enough.
Thorium power plants. China just brought one online.
You brought one online?
China just brought a thorium power plant online.
I see that as a future.
They've done a lot of other bad things too.
But to some extent, we see a parallel where in the late 60s, we essentially stopped all of our research on nuclear, and perhaps in the intervening 50 years, we would have come up with many ideas that would have been more useful. Well, in the past 20 years, we've gotten so focused on neural networks and now on LLMs that we really are not exploring all of the other areas of AI, which may also prove useful, but aren't going to show up if we don't explore them.
Yeah, there's going to be a resurgence of a lot of different things very soon, probably even this year. I'm bringing a few things back, and like your clauses are rules basically, and they're inference rules basically, and I think that inference systems might come back in a stronger way.
Mm-hmm. Expert systems even.
Yeah.
This is more related to your original question, but I think if we had some kind of Discord server or some chat room where we could all discuss these ideas in over a longer period of time, I think that would really help the brainstorming and whatnot.
That's a good idea, and we started down that road at some point, and a member put up a Discord server, but it didn't continue, and I don't know why. Do you know how to do that? And is it easy for you?
I mean, yeah, I could create a Discord server. I mean, it's not that difficult. I could probably add you as an admin or something.
Well,
I don't know if everyone here has a.
I don't know anything about Discord myself, so.
Or I mean, it doesn't have to be Discord. It's just some kind of general chat room. I mean, I know how to work with Discord, so I could make one on there. It's just I guess, what's the platform that most people here are comfortable with?
I have a larger which is I'm working on this system called Justify, and it's very close to becoming public. I've got a big server up now, and I am dreaming of having this particular group be able to hold discussions within Justify. But it's it has a lot more power than just this sequence of tweets and stuff. It's more. It's sort of like maybe a marriage between kind of UKS and Discord, where you're holding discussions, but the discussions are primarily organized based on semantics, not on time. Although I just built in a new thing about time, and I thought our discussion, Charles, you were talking about time. I think that kind of meta information, and I also have a new mechanism by which you can sort the points based on time. So you could get a time a sorting of all the points, as well as a semantic sorting in a hierarchy. And I think it's the combination of those two that allow you to have these more useful discussions, because it's not this stream of consciousness, or you can turn it into a stream of consciousness by showing time stuff, but the primary thing is the semantic stuff. And I think that's the primary thing of of the UKS2. And I loved when a part of your video, Charles, where you talk about it doesn't matter what order the information comes in, and we can put it in all these different orders, and ultimately we're building the same thing. And if we don't have a parent, just make up an unknown parent. We'll figure out its parent later. That's okay. Capture it. So that's kind of what I'm going for in this thing. So I don't know how long it's going to take, a month before it's reliable, a week, tomorrow, next year. I'm terrible at predicting software.
Well, by the way, I know nobody reads the comment streams on YouTube videos. I certainly don't. I watch the video and then I'm out of there. But the comment streams that are on the videos we have a lot of really interesting and insightful stuff. So if we were just able to consolidate even those, but as you know, it's scattered from here to there across 100 videos. It's useless.
Have the author give metadata like this is related to this part of the video. And then that's where the real because if the author can kind of control themselves and not just do this blabbering stuff, but place it and type it, this is a critique or this is a support of this particular concept, at minute 22.7. Now we've got something semantically more useful, because then when I'm confused around minute 22, I look and say, well, what are the other comments around 22? Oh yeah, this is relevant to, and then this guy asked the question and Charles answered it. Okay, great. Now I don't have to go to him and specifically get it, because he's put his answer in one place and it's findable in that one place. Mm-hmm. And that's what Justify is.
Well, we'll look forward to seeing it roll.
Yeah, me too. But you are informing its design, I can tell you that.
Oh, good.
And I think there may be some synergy here. And Michael as well, I guess. Yeah, Michael as well has got a lot of ideas that I pick up from, and conversations, and see where they can be woven in. Not everything, but it's.
Mm-hmm. Okay, I'd also, as we close up here, I'd like to invite any of you, if you'd like to have another conversation, let me know. We'll run these periodically, and
please do. They're so fun. I miss them.
I'm scrambling around trying to create some videos and write some software and do all of this stuff simultaneously, and also run these conversations now and then. So of course, we're all of us are spread thin, so we have to move forward. So if one of you has an idea for a conversation and would like to host something, let me know. I'll help you distribute it amongst the membership and get see if we can interest some parties to coming and visit. And I want to thank all of you for coming. I'll keep you posted as more videos come out. This one will be posted here shortly in the next couple of days, and I want to thank you all for coming, and I certainly appreciate it, and I look forward to talking with you all again. Okay, thank you. Bye.
Thank you. Bye.
If you're as excited about the future of AI as we are, hit the like button, subscribe, and drop a comment with your biggest AI questions.